Good day, everyone. We are going to discuss about the other continuous distributions. First is the Cauchy distribution. It is a distribution which I'll find useful for illustrative purpose, which is density f sub x minus x with parameters alpha and beta, which is equal to 1 over pi beta times 1 plus the square of the difference of x minus alpha over beta, where alpha is from negative infinity to positive infinity and beta is greater than 0. Cauchy distribution have cumulative density function given f of x is equal to 1 half plus 1 over pi arctan times x minus alpha over beta. Since Cauchy density is symmetrical about the parameter alpha, its mean and higher moments do not exist. So the second continuous distribution is the log-normal distribution. It is random variable x has log-normal distribution with parameters mu and sigma if its density is given by f of x is equal to 1 over the square root of 2 pi sigma x times exponent to the negative 1 over 2 sigma squared times the square difference of x minus mu, where mu is from negative infinity to positive infinity and sigma is greater than 0. It can be derived directly from the normal distribution by considering a log-normal distribution x and a normal distribution y, and letting x is equal to e to the capital Y, which is equal to g of y. Then y is equal to the natural logarithm of x, which is equal to g inverse of x. The derivative of g x inverse, the Jacobian, with respect to x is equal to 1 over x. Thus, f sub x of x is equal to f sub y of the natural logarithm of x times 1 over x, which is equal to the log-normal distribution above, or what I have this one. So it is an example of the log-normal distribution, the graph of log-normal distribution. Then the log-normal distribution have mean, which is equal to the e to the mu plus 1 half sigma squared, and variance, which is equal to e to the 2 mu plus 2 sigma squared minus e to the 2 mu plus sigma squared. So let y be a normally distributed function. Thus, its moment generating function is e to the mu t plus sigma squared t squared over 2, which is equal to the expected value of the moment generating function. Let x be a log-normally distributed function such that e to the y is equal to x. Thus, since the mean of x is equal to the expected value of x, the mean of x is also equal to the expected value of e to the y, which is when we say t is equal to 1 moment of y. Thus, the mean of x is e to the mu by substitution when t is equal to 1. So we have e to the mu plus sigma squared over 2. Likewise, the variance of x is equal to m sub y 2 minus m sub y 1 squared. So we have the variance e to the 2 mu plus 2 sigma squared minus e to the 2 mu plus sigma squared. The third one is the double exponential or the Laplace distribution. The probability density function of Laplace with parameters mu and sigma is f of x with parameters mu and sigma, which is equal to 1 over 2 sigma times the exponent of e to the negative x minus mu over sigma, where mu is from negative infinity to positive infinity and sigma is greater than 0. The mean and variance of the Laplace distribution. Mean is equal to mu and the variance is equal to 2 sigma squared. In finding the mean of the Laplace distribution, so given PDF of f of x with parameters mu and sigma is equal to 1 half sigma times e to the negative x minus mu over sigma, then the mean is mu. So by proof, let mu is equal to x minus mu. Then we have x is equal to mu u plus mu, and dx is equal to du. By linearity, we have expected value of x is equal to expected value of the big U plus mu, which is equal to the expected value of u plus mu. Then the expected value of x is equal to 1 over 2 sigma times the integral of of u e to the negative absolute value of u over sigma du plus mu evaluated from negative infinity to positive infinity, which is equal to 1 over 2 sigma times integral of u e to the u over sigma du plus 1 plus evaluated from negative infinity to 0 plus 1 half sigma times integral of u e to the negative u over sigma du evaluated from 0 to infinity plus mu, where mu is equal to the integral of u e to the u over sigma du evaluated from negative infinity to 0, which is equal to negative 1 over 2 sigma times integral of u e to the negative u over sigma du evaluated from 0 to infinity plus 1 half sigma times integral of u e to the negative u over sigma du plus mu evaluated from 0 to infinity. By cancellation law, the expected value of x is equal to mu. Then, in finding the variance of the Laplace distribution, we have expected value of x squared minus the expected value of the quantity of x, quantity squared of x. So proof, the expected value of x squared is equal to the expected value of e to the capital letter u plus mu squared, which is equal to expected value of capital U squared plus 2 mu times the expected value of capital U plus mu squared. Then we have expected value of the capital U squared plus 2 mu times the expected value of x minus u plus mu squared, which is equal to 1 half sigma times integral of u squared e to the negative u over sigma du plus mu squared evaluated from negative infinity to infinity, which is equal to 1 over 2 sigma times integral of u squared times e to the u over sigma du evaluated from negative infinity to 0 plus 1 half sigma times integral of u squared e to the negative u over sigma du plus mu squared evaluated from 0 to infinity. Then we have 1 half sigma times integral of u squared e to the negative u du negative u over sigma du evaluated from 0 to infinity plus 1 over 2 sigma times integral of u squared times e to the negative u over sigma du plus mu squared evaluated from 0 to infinity, which is equal to sigma squared times integral of v squared dv plus mu squared evaluated from 0 to infinity. Then we have the expected value of x squared is equal to 2 sigma squared plus mu squared, where gamma of n plus 1 is equal to the integral of v and e to the negative v evaluated from 0 to infinity, where dv is equal to n factorial for all n natural numbers. Thus, the variance of x is equal to the expected value of x squared minus the quantity of x, which is equal to 2 sigma squared plus mu squared minus mu squared, and by cancellation law, variance of x is equal to 2 sigma squared. Then fourth one is the Weibull distribution. The density f of x with parameters a and b is equal to a bx to the negative abx to the b minus 1 times the exponent of negative ax to the b indicator function of 0 to infinity of x, where a is greater than 0 and b is greater than 0. It is called the Weibull density, a distribution that has been successful in a reliability theory. The mean and variance of Weibull distribution is equal mean. We have 1 over a to the 1 over b times gamma, capital gamma of 1 plus b to the negative 1 or b inverse. Then the variance is equal to 1 over a to the 2 over b times gamma times the quantity of gamma times 1 plus 2b to the negative 1 minus gamma squared plus times 1 plus b inverse. In finding the mean of the Weibull density, the given PDF of f sub x with parameters a and b, the mean is equal to 1 over a to the 1 over b times gamma 1 plus b inverse. Proof. We have expected value of x is equal to the integral of f of x dx evaluated from negative infinity to positive infinity, which is equal to integral of x times a b x to the b minus 1 times exponent of to the negative ax to the b dx evaluated from 0 to infinity. Note that ax to the b is equal to t. X is equal to t over a to the 1 over b. Then dt is equal to ab x to the b minus 1 dx. Then we have integral of t over a to the 1 over b times the exponent of negative negative t dt evaluated from 0 to infinity, which is equal to a to the negative 1 over b times integral of t to the 1 over b plus 1 minus 1 times e to the negative t dt evaluated from 0 to infinity. Thus, the expected value of x is equal to 1 over a to the 1 over b times gamma 1 plus b inverse. Then, for the variance, we have integral of x squared times abx b minus 1 e to the negative ax to the b dx evaluated from 0 to infinity is equal to integral of t over a to the 2 over b times the exponent of negative t dt evaluated from 0 to infinity, which is equal to a to the negative 2 over b times integral of t to the 2 over b plus 1 minus 1 e to the negative t dt evaluated from 0 to infinity, which is equal to a to the negative 2b gamma 1 plus 2 over b. Then the variance of x is equal to a to the negative 2b times gamma plus 1 plus 2 over b minus a to the negative 2b gamma 1 plus 1 over b squared. Thus, variance of x is equal to 1 over a to the 2 over b times the value of gamma 1 plus 2b inverse minus gamma squared 1 plus b inverse. So, that is what we call the continuous distribution. I've introduced to you the four continuous distribution, namely the Cauchy distribution, log normal distribution, Laplace distribution, and the Weibull distribution. So, thank you for listening.